Hi, welcome to Unit 5, Day 2. This is Part 1, Preparing to Balance Chemical Equations. So in Unit 5, Day 1, what we covered was how to define a chemical reaction. And chemical reactions are something that involve a change. So what you start off with, your reactants, will change into something different, your products. So for example here, we're starting off with C3H8, also known as propane, and 3 oxygen molecules, and they combine together to form 3 carbon dioxides and 4 hydrogen gas molecules. So again, what we're starting off with are our reactants, and what we make are our products. We also learned how to express this chemical reaction using a chemical equation. So in a chemical equation like the one shown below, the reactants and products are separated by an arrow, and the arrow points toward the product side. And also you'll notice in the chemical equation that reactants are separated by plus signs. So if you have more than one reactant, use a plus sign to separate them. And the same thing with a product. If you have more than one product, use a plus sign to separate them. We also learn that chemical reaction equations must be balanced according to the law of conservation of mass, or also known as the law of conservation of matter. Now, when we say balance, it means that there's the same number of each type of atom on both sides of the arrow. Today, what we're going to do is we're going to learn how to balance a chemical equation. Now, in order for us to do that, it's important that we know the difference between the two numbers used in the chemical equation. We have subscripts, which are the small numbers that tell you how many atoms are within a molecule or element, and coefficients, which are the big numbers in front that tell you how many molecules or elements are in that reaction. So let's sort of recap one of the questions that we looked at yesterday, where it asked, what is the balanced chemical equation for this reaction? So we have this reaction here shown using a particle diagram, and we're going to convert this into a chemical equation. So the first thing that I noticed on my reactant side, I have aluminum. And I noticed that the aluminums are not connected, they're separated. And I have 2 separate aluminum. So because they're separated, I use a coefficient of 2. The second reactant I notice, I have HCl, and there are a total of 6 of them. So if I count each of those molecules up, there are 6. So I use a coefficient of 6 to express that there are 6 of them. Now on the product side, I have aluminum chloride, AlCl3. And notice that there are 3 chlorines, so in that case I use a subscript of 3 to show that there are 3 chlorines within one aluminum chloride molecule. And since I have a total of 2 of them, I use a coefficient of 2. Finally, I have H2, and once again, because there are 2 hydrogen atoms in a single H2 molecule, I use that subscript of 2. But since I have a total of 3 of them, I use a coefficient of 3. So when I write this into my chemical equation, it will look something like this that's shown below. 2Al plus 6HCl goes to form 2ACl3 plus 3H2. So notice that we're using the coefficients to count things that are not connected and the subscripts to count things that are connected within a molecule. And this is just another image of that. So if you were comparing, well, why wouldn't we write it as Al2, instead we write it as 2Al, this is what Al2 would look like. They would have to be connected in order for you to use that subscript. So let's see if we can sort of test that by matching the particle diagram shown on the left to the description. All right, so what you want to do for this is, you want to see which one of these, for example, for this first one here, you notice that there are 3 oxygen atoms. Are you going to use this 3O or the O3? So pause the video now. When you press play again, the answer will be revealed. Okay, so for the first one, because they're connected, we're going to use the subscript O3. For the second one, we have 2 separate oxygen atoms, so we use the coefficient of 2. Here we have 3 separate oxygen atoms, so we use a coefficient of 3. And here we have 2 oxygen atoms connected together, so when they're connected, we use that subscript. So this is the answer for CFU1. Okay, now that we sort of reviewed the difference between coefficients and subscripts, we're going to preview balancing chemical equations. Now remember, a balanced chemical equation has the same number of each type of atom on both sides of the arrow. So let's take a look at this equation and see if it's balanced. We have H2 plus O2 goes to form H2O. So in order to see if it's balanced, we're going to count the number of atoms on both sides of the arrow. Let's start on the reactant side, which is the side to the left of the arrow. I notice that I have 2 hydrogen atoms, and I know that there are 2 of them because the subscript 2 tells me that there are 2 of them. And then I notice I have 2 oxygen atoms, same thing because of that subscript. So I'm going to write, tally up 2 hydrogen and 2 oxygen atoms. Let's do the same thing on the product side. Now on the product side, I only have 1 molecule here, and in that molecule, I have 2 hydrogen atoms and 1 oxygen atom. Remember, if there's no subscript written, then it's an invisible one. Now, if I look to see if they're balanced, starting with the hydrogens, I have 2 hydrogens on both sides, so those are balanced. But what about the oxygen? They're not, because I have 2 oxygens on the reactant side, but only 1 on the product side. So this is not balanced because of the fact that the oxygen atoms on both sides are not the same. So now let's see, which method do you think is the best way to balance the equation? When we're balancing the equation, we have to change the number of atoms in order for them to be balanced. Now remember, there are 2 numbers that we're using in a chemical equation, subscripts and coefficients. So I want you to think about which method do you think is best. Let's start with method A, changing the subscript. So remember, I had 2 oxygen atoms on the reactant side and 2 on the product side. So if I wanted to get, 1 on the product side. If I wanted to get there to be 2 on the product side, I could just change the subscript of the product, the subscript of oxygen on the product side to 2. And in doing so, I get this, H2 plus O2 goes to form H2O2. And this is the particle diagram representing that equation. And as you can see, it's balanced, but is this the best method? Let's take a look at the second method, which is to change the coefficient. So in this case, once again, I had initially 1 oxygen atom on the product side, and I wanted to make that 2. So to do that, I wouldn't change the subscript, but I would just change the coefficient in front of H2O. And when I do that, there gives me 2 oxygens on the product side. Once I do that, however, I change the number of hydrogens as well. So I have to go back and change the number of hydrogen atoms on the reactant side to make sure that they're at balance. So in this case, I have to change 2 coefficients. And either way, I have a balanced equation. So which method is the best? Well, it turns out method B is the best. And the reason why method B is the best is because of the following. You can't change the subscript. And why can't you change the subscript? Well, the reason why you can't change the subscript is because when you change the subscript, you change the identity of the molecule, which changes the reaction completely. And when you're balancing an equation, you don't want to change the reaction, you just want to change the number of atoms on both sides, but keep the reaction the same. So what do I mean by changing the reaction? In our original reaction, we reacted H2 and O2 to produce water. And that's the same reaction that we see in method B. We're reacting H2 and O2 to produce water. So by changing the coefficient, we keep the reaction the same. However, in method A, we react H2 and O2 produce H2O2, which is also known as hydrogen peroxide. Hydrogen peroxide is not the same thing as water, so this is not the same exact reaction equation as the original. All right, so now that you've sort of seen what we're going to be doing here, what you're going to do is watch the balancing equation practice video. And while you're watching that video, you're going to write down what is written. Now, you can do that by printing out the handout that is linked, or you can do this on a separate piece of paper. One thing to note about the handout, it has additional questions that are helpful for the exit ticket that you'll take at the end. Finally, as you're watching the video, you may start to feel more confident. In that case, you want to start pausing the video before the answer is revealed and try to balance the equations on your own. And then you use the video to check your work. All right, that's it for this video. Have a quality day.